All right, so you ever look up and see one of those massive 500-ton airplanes just soaring through the sky and wonder, how in the world does it stay so perfectly straight? Well, I can tell you it's not magic. It's all about physics. And today, we are going to peel back the layers and uncover that very secret. I mean, seriously, what is stopping a machine that huge from just tumbling out of the sky? It's a fantastic question, right? And the answer is this really brilliant principle of physics. So let's get into it and break it all down, piece by piece. Okay, so our investigation is going to start by tackling what I like to call the stability riddle. Because really, what do we even mean when we say an airplane is stable? What does that actually look like? What we're talking about here is something called longitudinal stability. And really, all that means is it's the plane's natural instinct, its tendency to fix itself. So imagine a gust of wind knocks the nose up. A stable plane will, all on its own, push its nose right back down. It's the absolute bedrock of safe flight. But how does it actually do that? Well, to get to the bottom of that, we have to look at the forces at play here. And trust me, it is a very, very delicate balancing act. So most of us know about lift, right? That's the force from the wings that keeps the plane up. But that's only half the story. The real secret here, the key to stability, is something called the moment. Think of it as a twisting force, the thing that's constantly controlling whether the plane's nose pitches up or down. You know, the best way to picture this is to think of a simple seesaw. That pivot point in the middle, that's the airplane's center of gravity. And the forces pushing down on either end, well, that's like the lift from the wing and the force from the tail. It's all about keeping that seesaw balanced, because if you get that balance wrong, things can go from stable to very unstable, very, very fast. All right, so if we're going to crack this code, we have to figure out the total moment. And this is a seriously complex puzzle, you know? It's something engineers have to solve for every single aircraft that flies. Okay, so it basically boils down to 4 key twisting forces. And don't worry, we are not getting into the deep math here, but here's the gist of it. First, you've got the wing's own inherent twist. Then you add the tail's twist. After that, you have to factor in the twist created by the lift on the wing. And finally, you've got this really powerful twist coming from the lift on the tail. It's like this complex dance of forces all happening at once. So the whole point is this. The plane's stability is really just the final score in this constant aerodynamic tug of war. You add up all those 4 twisting forces, and the final number tells you if the plane is going to fly straight or fly into chaos. But here's the thing. It turns out one of these forces is the undisputed champion of this fight. And this brings us to the key clue in our whole investigation, the tail. It's hiding a secret weapon. A power that just completely, utterly dominates this balancing act. Now, engineers have a technical name for this. They call it VH. But for us, we're just going to call it tail power. And all it is a single number that measures the tail's leverage. It's a combination of how big the tail is and how far back it is from the center of gravity. So the rule is simple. The bigger the tail and the farther back it's placed, the more tail power it has. And this chart just lays it out perfectly. It's kind of crazy, but the wing's own lift actually creates a small twisting force that's trying to make the plane unstable. It's literally trying to pitch the nose up. But then you look at the tail's contribution, and it's just massive. It creates this huge, powerful force in the exact opposite direction, and that stabilizes the whole aircraft. Bottom line, the tail always wins. And we can even put some rough numbers on this. Let's say the wing's destabilizing force has a value of, I don't know, around 0.5. So what about the tail's tail power? Well, that number is often a 2, a 3, or sometimes even higher. It's not even a fair fight, a complete mismatch. The tail is just that much more powerful. Okay, so we've got all the clues, right? We've talked about the forces, the moments, this incredible tail power. And it all leads us to one simple, elegant, and frankly, absolutely critical conclusion. This is it. This is the big reveal, the golden rule of stability. And here it is. It's this simple. If something makes the nose pitch up, the total forces on the plane must automatically create a moment to push it back down. That's it. It's a built-in, self-correcting system. So how is that self-correction guaranteed? Well, it's guaranteed by making sure that tail power is just overwhelmingly larger than the wing's little tendency to destabilize things. That massive leverage from the tail is the insurance policy. It ensures that no matter what happens, the plane always wants to return to straight and level flight. But what happens when you break that rule? Well, this quote gives us a pretty chilling answer. It comes from the investigation of a real-life air disaster. A cargo plane was carrying livestock, and shortly after takeoff, a couple of bulls in the back just broke loose. They shifted all that weight suddenly to the very back of the plane, and the result was catastrophic. Let's just break down exactly what happened there. When those bulls shifted to the back, the plane's center of gravity, remember our seesaw pivot point? It moved backwards with them, and that did two terrible things at once. It dramatically reduced the tail's leverage, and at the same time, it increased the wing's destabilizing leverage. In a single instant, that delicate balance was completely shattered. The golden rule was broken, and the plane became totally, uncontrollably unstable. That tragic story is it's such a powerful, real-world lesson in how critical this balance really is. So when we get right down to it, the secret to a stable airplane isn't some ridiculously complex equation. It's a big, powerful tail set way back that's acting like a massive lever to constantly keep the airplane flying straight. That's it. That's the reason we can all fly so smoothly and safely. But that leaves us with one final and kind of fascinating puzzle. Think about it. If this whole system is designed to automatically push the nose down anytime it pitches up, then how is it possible for an airplane to cruise for hours with its nose pointing slightly up? Because they all do. It seems to completely contradict the golden rule we just figured out. And that, well, that's a riddle for another time.